Welcome to Networks Professionals.
All right, let's talk about one of the most maddening mysteries we all face. Why, oh why, does our internet connection decide to fail us at the worst possible moments? Today, we're going to crack the case. You know the feeling, right? You're deep into a video call, you're about to win an online match, or you're just trying to relax with a movie, and boom, everything freezes. It feels personal, but what if I told you your network is actually leaving you a trail of breadcrumbs? That's right. We are going to turn you from a frustrated user into a network detective. We're going to learn how to spot the signs, gather the evidence, and figure out exactly what's going wrong. And our investigation begins, of course, with opening up our detective's kit. Now, every good detective needs their tools. We're not talking about a magnifying glass or fingerprint dust, but we do have a few essential digital tools that will get our investigation started on the right foot. So, here's our game plan. It's a really simple 3-step process. First, we're going to check our own gear. Then, we'll see if we can even reach the place we're trying to go. And finally, we'll draw a map of the entire route to look for any trouble spots. You know, the first rule of troubleshooting anything is to make sure the problem isn't, well, you. And the loopback test is how we do that. It basically has your computer talk to itself. A signal goes out of the network card and comes right back in, without ever even touching the internet. If that works, hey, you can be sure your own machine is good to go. Okay, so your gear checks out. Now it's time to see if you can reach your destination. Ping is the simplest tool for this. It's the digital version of shouting, "Hey, are you there?" across a canyon and listening for an echo. If you get a reply, you know there's a path between you and your target. But what if that path is the problem? See, if ping is just asking, "Are you there?" traceroute is the full turn-by-turn GPS for your data. It shows you every single stop, every router, we call them hops, that your data makes along the way. And if there's a big delay or a total failure, traceroute will show you exactly where the traffic jam is. So we've confirmed there's a road from point A to point B. Fantastic. But just because the road is open doesn't mean it's a smooth ride, right? Now, we've got to gather some clues about the quality of that connection. First up, we need to get one thing straight: the difference between what you pay for and what you actually get. Bandwidth is the speed your internet provider sells you. Think of it like a giant, perfect 8-lane superhighway with no cars on it. But throughput, that's your real-world speed. That's the same highway, but now it's rush hour, and things are a whole lot slower. And here's a word that sends a shiver down every gamer's spine: latency. We all know it as lag. It's just the time it takes for one little piece of data to travel from you to a server and back again. High latency is that infuriating delay between when you click your mouse and when your character actually does something on screen. Now, jitter is a little sneakier. It's not about how long the delay is, but how unpredictable it is. Imagine some of your data arrives in 30 milliseconds, but the next chunk takes 150. Your computer is scrambling to put it all back together in the right order. This is why your video calls sound all robotic and choppy, even if your download speeds seem fine. If that's happening, jitter is your prime suspect. And sometimes, the data doesn't just get delayed, it just vanishes into thin air. That's called packet loss. When a piece of data goes missing, your computer has to notice it's gone and ask for it to be sent all over again. This is the culprit behind stuttering online games or a video stream that suddenly has to stop and buffer. It's literally waiting for lost mail to be resent. Okay, now we know how to measure the evidence. It's time to identify the actual culprits behind the crime. Let's line up our rogues gallery of the most common network villains. So, believe it or not, most network headaches can be traced back to one of these 3 characters. They all cause trouble in their own unique way, but the result is always the same: a slow, frustrating experience for you. First on our list is the bottleneck. Let's go back to that 8-lane superhighway. Now imagine all 8 lanes suddenly have to merge into one single country lane. That's a bottleneck. It doesn't matter how fast the rest of the path is. All of your data has to slow to a crawl to squeeze through that one tiny point. Next, we have the flapping link. And this one sounds pretty much like what it is. It's a connection, maybe a loose cable, maybe faulty hardware, that's constantly turning on and off. For the network, this is pure chaos. The routers keep trying to map a new path around the problem, but then the problem disappears, then it comes back. It creates total instability. And our final suspect is a bit technical: the MTU mismatch. Just think of MTU as a package size limit for every road on the internet. Every piece of equipment has a rule about the biggest chunk of data it can handle at one time. So, what happens if your computer tries to send a package that's too big for one of the roads on its journey? Well, that package has to be stopped, opened up, and broken down into smaller pieces. This whole process is called fragmentation, and it adds a ton of extra work, slowing everything down while the computer on the other end tries to reassemble all the little bits. Now, to be a really great detective, you can't just look at the suspects. You have to understand the whole crime scene. So let's zoom out for a second and look at the bigger picture of the network itself. At a high level, networks are organized into what we call domains. Think of older stuff, a collision domain, like a one-lane road, where only one car can go at a time or they'll crash. Modern networks are more like a broadcast domain, which is like a neighborhood where you can shout a message and everyone on the street hears it at once. Understanding this is like understanding the city planning of the internet. And finally, there's the network's reaction time, which we call convergence. So when a link fails, think of it as a sudden road closure on the highway. How long does it take for all the other routers to get the news and figure out a new route? A fast convergence time means the network heals itself almost instantly, which is absolutely key to a stable connection. And there you have it. In just a few minutes, we've gone from being the victim of a mysterious bad connection to being the detective who can actually diagnose it. You've learned the language, words like ping, latency, bottleneck, MTU, and now you can understand the clues your network is leaving for you. So, the next time your internet starts acting up, don't just get frustrated, get curious. Start your investigation. You've got the tools. You are now the detective. So, what is your network trying to tell you? Thanks for tuning in.
Thanks for watching.